everyone, in today's video I will be going through the practice test for Unit 5. So number 1 here, notice that we have different indexes. We have a cube root and we have a fifth root. So I'm going to start this problem by rewriting each one with a fractional exponent. So remember, think of inside out. So the inside number is your numerator and the outside number is your denominator. From here, whenever you are multiplying two of the same letters or same variables, that's the product property. And the product property tells us that we need to add these two fractions. So we're going to add 2/3 plus 3/5. And just a reminder, you are able to add that in your calculator without getting a common denominator. So when I do that, I end up with 19/15. So my answer for number 1 is x to the 19/15, and I can just leave my answer in that form. Moving into number 2, now I am looking at something that has the same index. So they're both cube roots. I'm going to start this problem by writing it under one large radical. From here, I want to simplify inside the radical first before I actually take the cube root of anything. So underneath the radical, I'm going to divide 32 by 4, which gives me 8, and I'm going to subtract my exponents here. So I end up with m to the 12th. Now, at this point, I can think about taking the cube root of 8 and taking the cube root of m to the 12th. So cube root of 8, which you can do in your calculator, is going to give you 2. When you're taking the cube root of a variable, you can think about grouping or dividing. So if I have 12 m's and I need to make groups of 3 because it's a cube root, I make 4 groups of 3. So I get m to the 4th. Again, you can think about dividing 12 by 3, which gives you 4. Okay, number 3 is similar to number 2, so I'm actually going to look at this as two different pieces. Since we have negative exponents, I'm going to start by switching these two. So the negative exponent, if something is in the numerator with a negative exponent, it will move to the denominator. If something is in the denominator with the negative exponent, it will move to the numerator. So I'm first going to switch those two, and then I'm going to put the second part under one radical, just like I did in number 2. So I have something like this. From here, I'm going to use my division rule for 7 to the 6th over 7 to the 5th. So I'm thinking about subtracting 6 and 5. So I get 7 to the power of 1. Now let's simplify underneath the radical. So if I divide 162 by 2, I'm left with 81. And again, I'm subtracting the exponents, so I get n to the 20th. Just like number 2, I can go ahead and actually take the 4th root of 81 and take the 4th root of n to the 20th. So just a reminder, if you're in your calculator, to get to the 4th root or any root, you want to click on Math. You want to go down to number 5 and click Enter. You can type 4 into the index, and in this case, we need to find 4th root of 81. So this gives me 3, and then I'm thinking about dividing 20 by 4, so I get n to the 5th. I still have 7 to the 1st power, which is just 7, and I will multiply it to 3n to the 5th, and I end up with 21n to the 5th. Moving along to number 4, I see that I have a negative exponent in my denominator. So just like I did with number 3, I'm going to move everything to the numerator. So I end up with 27 to the 1/3, m to the 3/4, all to the power of 4. Technically, it's all over 1. Now there's a couple things we can do. We can distribute the 4 first, or we can simplify inside the radical. So I'm going to go ahead and distribute this 4, and when I do that, I will multiply the exponent inside with that 4 on the outside. So I end up with 27 to the 4/3 and m to the 12/4. From here, we can actually plug this first term into the calculator, and when you do that, you will get 81 back out. And then we can simplify 12 over 4 and be left with m cubed. And looking at number 5, I'm going to look at this as 3 separate pieces for now. So the 5th root of 1024, 5th root of x to the 30th, and the 5th root of y to the 15th. So that first term you can go ahead and type into the calculator to figure out what that value is. When I do that, I get 4. When you're dealing with the variables, you want to think about dividing. So 30 divided by 5, which gives us 6. And then 15 divided by 5, which is going to give me 3. So my answer for x to the 6, y cubed. Okay, number 6, we're given 2 functions. So we have an f of x, we have a g of x, and we're asked to find f of g. Just a reminder, this is another way of writing f of g. So we're going to take function g and plug it into function f. So g will get plugged into f. In this case, it will get plugged in twice because there are 2 x's in f. So I am replacing x with my g function. From here, always remember that anything that's squared implies that you have 2 of them. So you need to double distribute that 2x minus 1. And then I'm going to go ahead and distribute my 3 in to 2x minus 1. Right, continuing along, I'm multiplying these 2 binomials together. And from here, I just want to combine all of my like terms. So I have 4x squared. And then I'm going to highlight my x's so I can go ahead and combine those. And then I'm going to combine all of my constants. So I end up with 4x squared minus 10x plus 34. Okay, number 7. This one's going to be a little bit different. Now we're looking at function compositions. We're still dealing with 2 different functions though. We have f and g, so we're going to add, subtract, multiply, and divide these 2 functions together. So part A, we are adding, so I'm just going to combine my like terms. X squared minus 2x plus 4. When you're dealing with subtraction, you want to make sure that you put parentheses around your second term. That way you can distribute that -1 to every term before you combine. So from here, if I'm combining like terms, I'm going to end up with -x squared plus 14x minus 26. multiplying. So you can set up multiplication like this, where you're going to distribute everything from F into G. Some people also like to set up a Punnett square, so I'm going to go ahead and show you guys that way using the square. This helps you keep all your terms organized. Either way, you should end up with the same answer. So when I multiply in the Punnett square, I'm going to look at each row and each column. So I have 6x cubed minus 48x squared, 90x, negative 11x squared, positive 88x, and a negative 165. So now we're going to combine like terms. We only have one x cubed function or a term, so 6x cubed. We can combine the x squareds. We get minus 59x squared. Combine our x's. Plus 178x, and then minus 165. So the square helps you keep everything organized. Okay, part D. So part D, we need to do two parts. We need to write the function. So 6x minus 11 over x squared minus 8x plus 15. So that's the function part. Now we need to think about the restriction. In the restriction, you want to look at the denominator and set it equal to 0. From here, you can think about using quadratic formula or factoring. So if we are factoring, we're thinking about two numbers that add to negative 8, but multiply to 15x squared. So two numbers here would be negative 3 and negative 5. So I have x minus 3, x minus 5 equal to 0. If I set those each equal to 0, my restriction will be x cannot equal 3 and x cannot equal 5. Those are the two values that would make my denominator 0. Moving along to number 8, we have a function composition. So we have g of f of x. We're going to take f and plug it into g. So f gets plugged into g. So I have 5 over 15x to the 3/4. From here, we're going to go ahead and simplify a few things, starting with the 5 over 15. That will simplify to 1/3 x to the 3/4. Now we need to do something called rationalizing. We can't keep that x to the 3/4 in the denominator, so I'm going to think about making that denominator whole, and I'm going to multiply by x to the 1/4 in the numerator and in the denominator. So by doing that, I end up with x to the 1/4 in the numerator over 3x, because I'm adding 3/4 plus 1/4. So I made that denominator whole. The last thing is to just rewrite the numerator as a radical. So we get answer D. Right, number 9 is asking us to find the inverse of this function. So remember, the first step with the inverse is switching your x and y position. So I end up with x equals 1/3 y to the 5th plus 7. And now you're trying to isolate y. So I'm going to start by moving that 7 to the other side. That gives me x minus 7 equals 1/3 y to the 5th. Again, focus on isolating y. To get rid of this 1/3, I'm going to multiply by the reciprocal. make sure you distribute that 3 to the x and the 7. So you have 3x minus 21 equals y to the 5th. And last step to get rid of that y to the 5th, we're going to take the 5th root of both sides. So our inverse function is the 5th root of 3x minus 21. Number 10 is also talking about inverse functions. Now we're given f of x and g of x, and we need to test whether they're inverses or not. So in order to figure that out, we're going to start with f of g. So if I do that, I'm going to take g, which is negative x plus 2, and plug it into f. Once I simplify, I get negative x. In order for functions to be inverses of each other, they need to simplify to just x. So these would not be inverses. Our answer here is going to be letter D. Not inverse functions because it does not equal x. And the next 4 problems involve graphing. So just remember that when we're graphing, our form is h and k, and the h is always opposite for both square root and cube root. H and k will give you very special points for each function. So number 11, my h is 2 and my k is 3, which is going to give me my starting point. That's the first dot I'm going to make. When you're dealing with square roots, you can follow the pattern. So we're going to go over and up 1 from the starting point, go back to the beginning and go over 4 to the right, and up 2, and connect our dots. Our domain starts at 2 and it goes to the right, so that's positive infinity. Our range starts at 3 and is above 3, so that also goes to positive infinity. Translation, we moved right 2 and up 3 from the origin. And our end behavior, as x goes to 2, f of x goes to 3, that's what's happening on the left side. And as x goes to positive infinity, f of x goes to positive infinity. Okay, number 12 is very similar, except we have a negative sign. So our graph will be reflected. My starting point is negative 1, negative 4, because that's my h and my k. It's still going to point to the right, but now I'm going to go over to the right and down 1, over 4, and down 2, because it's reflected, so it looks something like this. Domain is negative 1 to positive infinity. My range is negative infinity up until negative 4. Translation, left 1, down 4, and you can also include reflected. End behavior, as x goes to negative 1, f of x goes to negative 4, and as x goes to positive infinity, f of x goes to negative infinity. 13 and 14 are cube roots, so our graph will be S-shaped. We're still going to start with looking at our h and our k. Remember, h is opposite, so our turning point is negative 2, negative 5. This is a positive cube root, so I'm going to go up into the right one, down into the left one. I made a little positive line with my 3 points, and now I'm going to connect to make an S-shaped graph. Remember, domain and range for all cube roots is just all real numbers. They go on forever, left and right, and up and down. My translation is left 2, down 5. And behavior, as x goes to negative infinity, that's the left side. F of x goes to negative infinity. And on the right side, f of x goes to positive infinity. Right, 14 is very similar, except we have a negative, so our s will be going the other way. But again, I'm starting with h and k for my turning point. And now I'm going left and up 1, right and down 1. I made a negative line with my 3 points. Domain and range does not change here. Translation is right 5, up 2, and you can also include reflected. My end behavior will change just a little bit, so my left side is now going to positive infinity, and my right side goes to negative infinity. So it's opposite from 13. Okay, 15 asks us to explain what each of the letters do in the parent function, in the translated function. So a negative a reflects across the x-axis. A is greater than 1, that's going to be a stretch. If a is between 0 and 1, that's a compression. H is your left and right shift from the parent function. And you want to make sure that you take the opposite of H. K is your up and down shift. All right, 16 and 17, we're moving into solving. So for 16, our radicals already isolated to one side. I'm going to go straight into squaring. On the left side, I'm left with 2x minus 7 because the square root and the squared cancels out. But on the right side, I'm going to write this out twice because I need to double distribute. So I end up with x squared minus 5x plus 25. From here, I want to move everything to one side and combine my like terms. So that way I can go into quadratic or factoring. So I will have 0 equals x squared minus 12x plus 32. I'm going to factor, so I'm going to think about something plus something equals negative 12x. Something times something equals 32x squared. I get 4 and 8, but they both need to be negative. So x minus 4, x minus 8, which means x equals 4 and x equals 8. So I'm going to go ahead and check both of these. You can check this in your calculator. So if you go into the y equals, you can go ahead and type each side into each line. So y1 is going to be your left side, y2 is going to be your right side. And you want to go to second graph to look at the table. So our two answers were 4 and 8. So if I look at 4, notice that my two y values are different, so 4 is not going to work. If I go to 8, notice that my two y values are the same. So that tells me that x equals 8 is my only answer, and x equals 4 is extraneous. 17. When solving the following equation, you get x equals negative 7 and x equals negative 2. Determine which is the extraneous solution and explain why. So I'm going to go ahead and plug in each of these values and see if they are true in the equation. So if I plug in negative 7, I end up with negative 4 equals the square root of 16, which would be negative 4 equals 4. That is not true. We should also check negative 2. So I get 1 equals the square root of 1. So 1 equals 1. That is true. So x equals -7 is extraneous because -4 does not equal 4. So that's just one explanation. You guys can always use different explanations as long as you show why one of them didn't work. All right, moving into 18. So we have a particular jeweler with this formula. They tell us that it's $3.50 per carat. We want to know how much a pearl is going to cost if it has a 7.1 millimeter average diameter. So we know the diameter of this pearl, but we don't know the weight. And we need to figure out the weight before we get the total cost. So we're going to start by plugging in 7.1 for diameter. And we are going to try to solve for W. So I'm going to start by cubing both sides to get rid of that cube root. I get 357.911 equals 4W over 0.02847. I'm going to now multiply by 0.2847 on both sides. I get a pretty long decimal. When you're working on this problem, I would recommend typing everything into your calculator and not rounding any of the decimals. Last step to get W by itself is going to be divide by 4. So we figure out the weight is about 2.5 carats. To figure out the total cost, we're going to take that weight and multiply it by $3.50. So we end up with $8.92 for the total cost of the pearl. Right, number 19, we want to express this in reduced radical form. So we're going to think about rationalizing the denominator. You want to think about the word conjugate. So we're going to multiply the numerator by 4 minus square root of 3 and the denominator by 4 minus square root of 3, which is the conjugate of the denominator. So we're going to distribute the 7. We get 28 minus 7 square root of 3. In the denominator, you want to double distribute. So 16 minus 4 root 3 plus 4 root 3 minus 3. What's going to happen is your radicals will cancel out in the denominator. So we have 28 minus 7 square root of 3 over 13. Okay, the very last problem wants us to look at this function and select all that is true. So I'm going to draw a rough sketch of this. It's a square root function, and I know my starting point is at -2, -7. And it's positive. So it's going to look something like this. Okay, so looking at f and g, as x goes to positive infinity, f of x is going up, so it's going to positive. We have a positive function, so we are constantly increasing. Since we have this starting point, the domain is not all real numbers. It starts right here at -2, so k is correct. And the range starts down here at -7. So those are all the statements that are true. Okay, please make sure you review your study guide before the day of your test. If you have any questions, please reach out to your teacher.